Getting ready for an interview can be a daunting task, especially when it's for a Unix-based role. Our video on Top 25 Unix Interview Questions and Answers is designed to prepare you for just that. In this video, we will discuss frequently asked Unix questions and provide in-depth answers to each one. The aim is to equip you with the knowledge needed to excel in your upcoming Unix interview. 1. What is Unix? Explain its key features. Unix is a powerful, multi-user and multitasking operating system that was originally developed in the 1970s at AT&T Bell Laboratories. It is designed to provide a simple, yet powerful, interface for users and has been influential in the development of many modern operating systems. Key features of Unix include multi-user capability. Unix allows multiple users to access the system and its resources simultaneously. This is particularly beneficial in a networked environment. Multitasking. Unix supports the concurrent execution of multiple tasks. This means you can have multiple programs running at the same time. Portability. Unix was written in the C programming language, making it easier to modify, adapt, and transfer to different machines. File system. Unix treats everything as a file, including hardware devices, processes, and streams. This makes it simpler for users and developers to manipulate these resources. Security features. Unix has robust security features, such as file permissions and access controls, that protect the system and its data from unauthorized access. Pipes and filters. Unix provides a set of simple tools that can be chained together through a mechanism known as pipes and filters to perform complex tasks. Scripting languages. Unix supports a variety of powerful scripting languages, such as shell scripting, Perl, and Python, that automate routine tasks and enhance the functionality of the system. Unix's design philosophy centers on simplicity and the idea that everything is a file. 2. What are the differences between Unix and Linux? Unix and Linux are two operating systems that share many similarities but also have distinct differences. Unix is a proprietary operating system developed by AT&T in the 1970s. It is known for its stability, scalability, and reliability, making it a popular choice for servers and mainframes. Linux, on the other hand, is an open-source operating system that was created by Linus Torvalds in the 1990s. It was based on the Unix design but developed to be free and customizable. Because of its open-source nature, many different versions or distributions of Linux exist, such as Ubuntu, Fedora, and Debian. Some key differences between Unix and Linux include their licensing, cost, and user base. Unix is commercial software that requires a license to use, while Linux is free and can be modified and distributed by anyone. This has led to a broader and more diverse user base for Linux. Additionally, while both systems are known for their command line interfaces, Linux distributions often come with graphical user interfaces, GUIs, that make them more user-friendly. In terms of performance, both systems are comparable, though some claim that Unix is more stable and powerful, while others argue that Linux is more flexible and adaptable due to its open-source nature. 3. What is the purpose of the file system in Unix? The file system in Unix serves a crucial role by managing how data is stored and retrieved. It provides the means for storing data in files and directories, and organizing these in a way that makes data retrieval efficient. Each file or directory is represented by an inode, a unique identifier that contains important information about the file or directory such as its size, owner, and access permissions. The file system also ensures data integrity and reliability, supporting features such as journaling and backup capabilities. The Unix file system is hierarchical, meaning it starts from a root directory, represented by, with various subdirectories branching off. This structure makes it easy for users to navigate and organize their files. Additionally, the Unix file system follows a philosophy of everything is a file. Even hardware devices and system resources are treated as files, allowing for consistent and simple data manipulation. 4. Explain the concept of a process in Unix. A process in Unix is essentially a program that is currently running on your system. Each process, once initiated, is assigned a unique process identification number, PID, which is utilized by the system to manage process execution. The process in Unix is either user-initiated or system-initiated. User-initiated processes are those that are launched by the user, while system-initiated processes are generated by the system to perform background tasks. A process can be in one of several states: running, sleeping, stopped, or zombie. Processes in Unix can also have child processes. The parent process creates child processes, which in turn can form their own child processes, forming a process hierarchy. The PS command is used to monitor these processes. Understanding and managing processes are important to effectively control the Unix system, as it allows for efficient utilization of resources and can prevent the system from becoming overburdened. 5. What is the significance of the kernel in Unix? The kernel is a core component of the Unix operating system. It is responsible for managing the system's resources and the communication between hardware and software components. As the heart of the OS, the kernel has complete control over everything in the system. It is the part of the operating system that loads first, and it remains in the main memory. Because it stays in memory, it can manage the system's memory effectively and be readily accessible to execute any process. The kernel performs various functionalities such as process creation, deletion, file system management, device management, and network communication. Its other roles include managing the CPU's resources, allocating and deallocating memory, and determining the priority level for processes. By doing so, the kernel ensures smooth and efficient performance of the Unix system. 6. How do you list files in directory? What command do you use? In Unix, we use the ls command to list files in a directory. This command is one of the most frequently used commands, and it displays the list of files or directories in the current directory by default. If you want to see the list of files in another directory, you can specify the directory path after the command. For instance, ls home user documents will list all the files in the documents directory of the user's home directory. The ls command also supports several options to modify its behavior. For example, lsl provides a long listing format which includes additional information such as file permissions, number of links, owner, group, size, and time of last modification. 7. Explain the use of the chmod command. How do you change file permissions? Chmod is a fundamental command in Unix systems. It stands for change mode and is used to alter the permissions of a file or directory. File permissions dictate who can read, write, or execute a file. There are 3 types of access: read, R, write, W, and execute, X, and 3 types of users: owner, U, group, G, and others, O. To change the file permissions, you would use the chmod command followed by a numerical value representing the permissions and the name of the file or directory. The numerical values are 4 for read, 2 for write, and 1 for execute. For example, chmod 754 file name would give the owner full permissions, the group read and execute permissions, and others only read permission. The chmod command in Unix is an essential tool for managing file security. By controlling who has the ability to read, write, or execute a file, you can protect sensitive data and prevent unauthorized modifications. It's important to understand the numeric system for setting permissions and to use it correctly to maintain the desired level of access control. In addition, always ensure you are making changes to the correct file or directory, as incorrect use of chmod can result in loss of access or exposure of data. 8. What does the grep command do? Provide an example of its usage. The grep command, which stands for Global Regular Expression Print, is an essential utility in Unix and Linux systems. It is used to search for a specific pattern within files. The grep command can also be used to search through multiple files or even through output from other commands. For example, if you want to find all occurrences of the word Unix in a file named sample.txt, you would use the following command: grep Unix sample.txt. This command will scan through the entire file and print out each line that contains the word Unix. If you want to make your search case insensitive, you can add the I option, grep I Unix sample.txt. This will match Unix, 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 and any other combination of upper and lower case letters. 9. How can you find the current working directory in Unix? To locate the current working directory in Unix, use the pwd command, which stands for print working directory. When executed, it produces the full system path to the current directory, beginning from the root directory. This is a useful tool for confirming your location within the file system, especially if you have navigated through multiple directories. It can also assist in preventing errors when running other commands that depend on the current directory. For instance, if you're going to move or copy files, it's crucial to verify your current location before executing the command. 10. What is a symbolic link, and how do you create one? A symbolic link, also known as a symlink or soft link, is a special kind of file that points to another file or directory. It's a reference to the original file or directory, rather than a copy of the file. This is beneficial when there are large files or directories that need to be accessed frequently, as it saves disk space and simplifies the access path. To create a symbolic link in Unix, you use the lane command with the s option. The basic syntax is lane s target source. Here, the target is the existing file or directory, and the source is the link to be created. If the source name is not given, a link with the same name is created in the current directory. For example, to create a symbolic link named my_link, that points to a file named my_file, you would use the following command: lane s my_file my_link. 11. Describe the difference between hard links and soft links. Hard links and soft links, also known as symbolic links, are 2 types of links in Unix. A hard link is essentially a mirror of a file. It points to the same inode as the original file, and changes in either the link or the original file are reflected in the other. Hard links can only be created for files in the same file system and cannot be created for directories. On the other hand, a soft link is more like a shortcut to a file or directory. A soft link points to the file location, not the inode. Thus, changes in the original file are not reflected in the soft link. Unlike hard links, soft links can link to directories and can cross file system boundaries. If the original file is deleted, a soft link becomes a broken link, while a hard link remains accessible. 12. How do you view the content of file in Unix? Name at least 3 commands. In Unix, you can view the content of a file using several commands such as cat, more, and less. The cat command is used to concatenate and display files. It reads data from the file and gives their content as output. To use it, you simply type cat followed by the file name. The more command allows you to view the contents of a file one page at a time. This is particularly useful if the file is very large and you want to read it page by page. To use it, you type more followed by the file name. The less command is an improved version of the more command. It allows backward movement in the file as well as forward movement. Also, less does not have to read the entire input file before starting, so with large input files, it starts up faster than text editors like V. To use it, you type less followed by the file name. 13. What is the purpose of the tar command? How do you create and extract a tar file? The tar tape archive command in Unix is a tool used to create, maintain, modify, and extract files that are archived in the tar format. It allows users to gather multiple files into one larger file for easier distribution or backup. To create a .tar file, you use the command tar cvf filename.tar path to directory. This command creates a tar file named filename.tar from the directory specified. The C option tells tar to create a new archive, the V option makes tar talk a lot, verbose, and the F option allows you to specify the name of the archive. To extract a .tar file, you use the command tar xvf filename.tar. This command extracts the tar file named filename.tar. The X option tells tar to extract the archive, the V option makes tar talk a lot, verbose, and the F option allows you to specify the name of the archive. These commands provide a simple way to package multiple files and directories into one file and then extract them back to their original state, preserving their original attributes and permissions. 14. What are the common file types found in Unix? In Unix, there are 3 main file types, which are regular files, directories, and special files. Regular files, also known as ordinary files, most commonly contain text, but they may also contain binary information. Directories are essentially a table that the system uses to map file names to inodes. They hold 2 types of information: file names and inode numbers. Special files are used to represent hardware and software devices on the system. These can be further categorized as either block special files or character special files. Block special file is used for a device that handles data in blocks, like a hard drive. Character special files are used for input-output devices that process one character at a time, like keyboards and printers. 15. Explain the concept of inodes in the Unix file system. The idea of an inode, index node, is fundamental to the Unix file system. Each file or directory is identified by an inode, which is a data structure that holds information about the file or directory. The inode contains metadata such as the file's size, its file type, the time it was last accessed or modified, and permissions. However, the inode does not contain the file's name or its actual data. These are stored elsewhere in the file system. The inode number acts as a unique identifier for each file and directory within a file system. A file's data blocks and inode are linked by the inode number. An inode can provide a directory listing which includes inode numbers and file names, allowing the system to access the metadata and data for any file. 16. How do you check the system uptime and load average in Unix? To check the system uptime and load average in Unix, you can use the uptime command. This command provides a one-line display of the following information: the current time, how long the system has been running, how many users are currently logged on, and the system load averages for the past 1, 5, and 15 minutes. The uptime is a measure of how long the system has been operational without a restart. The load average values give you a rough idea of system resource usage. A high load average means that the system is being heavily used, possibly to the point of affecting performance. To check the system uptime, simply type uptime into the terminal and press enter. The output will look something like this: 14 hours 1 minute and 26 seconds up 5 days, 316, 1 user, load average 0.00, 0.01, 0.05. This output can be interpreted as follows: the current time is 14 hours 1 minute and 26 seconds. The system has been running for 5 days and 3 hours, 16 minutes. There is 1 user currently logged on. The system load averages for the past 1, 5, and 15 minutes are 0.00, 0.01, and 0.05, respectively. 17. What commands would you use to monitor system performance? To monitor system performance, there are several commands you can utilize. The top command gives a real-time, dynamic view of the processes running on a system. It can display information such as processor activity, memory usage, swap usage, and more. The vmstat command provides a snapshot of everything happening in the system. It can display system-wide statistics of processes, memory, paging, block I/O, traps, and CPU activity. The iostat command is used for monitoring system input-output device loading by observing the time devices are active in relation to their average transfer rates. The netstat command is a versatile tool for network statistics. It can display network connections, routing tables, interface statistics, masquerade connections, and multicast memberships. For disk usage, the df command is used. It can display the amount of disk space used and available on file systems. Remember, each command will have a variety of flags and options to provide more specific or detailed information. 18. How do you schedule a task to run at a specific time in Unix? In Unix, you can schedule a task to run at a specific time using the cron command. This command allows you to run scripts or commands at preset times and dates. You can set up a cron job by editing the crontab file. To do this, type crontab E in your terminal. This will open up your cron table in a text editor. Each line of the crontab file represents a single job and is composed of a cron expression followed by a command to be run. The cron expression is a string of 5 fields separated by spaces, indicating when the job should be carried out. The fields represent, in order, minute, 0 to 59, hour, 0 to 23, day of the month, 1 to 31, month, 1 to 12, and day of the week, 0 to 7. After setting up your jobs, save and close the file to start the scheduled tasks. For example, if you want to run a script called test.sh every Monday at 5 p.m., you would add the following line to your crontab file: 017***1/path/to/test.sh. 19. How can you check network connectivity in Unix? Name a command. To check network connectivity in Unix, you can use the ping command. This command sends a series of echo request packets to a specified IP address or domain. If the destination is reachable, it will respond with echo reply packets. Here's an example of how to use it. Ping www.example.com. In this command, replace www.example.com with the IP address or domain you want to check connectivity to. The command will run indefinitely until you stop it, usually by pressing Ctrl+C. The output will show you details about the packets sent, received, and lost during the test, as well as the time each packet took to receive a response. This can be a useful tool for diagnosing network issues or testing your network's performance. If you want to ping only a specific number of times, you can use the C option, followed by the number of times you want to ping. For example, ping C4 www.example.com. In this command, the ping command will stop after sending 4 echo request packets. 20. What are some common security practices for Unix systems? The security of Unix systems is crucial to prevent unauthorized access and maintain the integrity of data. Some common security measures include regular system updates. Keeping the system updated is essential to patch any security vulnerabilities. Strong passwords. Enforcing the use of strong, complex passwords can prevent unauthorized access. Limited root access. Limiting the number of users with root access can greatly reduce the potential for system compromise. User account management. Regularly reviewing user accounts and disabling any that are no longer needed can also enhance security. File permission management. Setting appropriate file permissions can prevent unauthorized access to sensitive data. Use of firewall. A well-configured firewall can protect the system from external threats. Regular backups. Regular backups are necessary to ensure data recovery in case of any data loss. Use of security tools. There are various security tools available for Unix systems like antivirus, intrusion detection systems, IDS, etc. These tools can detect and prevent potential threats. Following these practices can significantly increase the security of a Unix system.